This is the exercise for word embeddings. Today we are going to explore pre-trained embeddings. So the code we will work on today showcases the use of pre-trained word embeddings to represent words as vectors in a high-dimensional space. It demonstrates how to load pre-trained embeddings, access specific word vectors, find words similar to a given word, and calculate the cosine similarity between word vectors. Moving on to our first line of code. Over here, what we are trying to do is we are trying to download and load the pre-trained word embeddings from the Globe model with this line of code. So specifically, the Globe Wiki Gigawatt 100 variant is what we are trying to load. So the wiki embed variable will hold the loaded word embeddings. The word vectors in this model have a length of 100, as you can see over here. So the length of 100 is given over here. So moving on to our next line of code. With this line, what we are trying to do is we are trying to print the length of the word vector corresponding to the word king. It demonstrates that the word vector has a length of 100. Moving on to our next line of code. Over here, wiki embed king syntax retrieves the word vector associated with the word king from the wiki embed object, which contains the loaded pre-trained embeddings. The word vector is a 100-dimensional vector that represents the semantic and syntactic information of a word king in the embedding space. And lastly, this line of code simply prints the value of king variable. You can see over here. Moving on, in the next line of code, what we are trying to do is we are trying to find the words most similar to king based on trained word vectors. So over here with this line of code, we will find and print the words most similar to a king based on the trained word vectors. It uses the pre-trained embeddings to compute the similarity between word vectors and provides a list of similar words. So, most similar method returns a list of tuples where each tuple contains a word and its similarity scored with respect to word king. So we can see words like prince, queen, and its similarity score is right over here. Moving on to next line of code. Over here, these two lines are trying to do is they are retrieving the word vector for the word queen and apple from the pre-trained embeddings stored in the wiki embed object. And later on, these three lines are used to reshape the vectors as 2D arrays or nested lists. So what is happening is they are reshaped as 2D arrays or nested lists, as it is often necessary when calculating cosine similarity using libraries like scikit-learn, which expect input vectors to be in specific format. The vectors are wrapped inside square brackets to create a single item list. Now in the last part of code, what we will do is we will try to find cosine similarity. So one might ask, what is this? So this is by calculating this cosine similarity, we can measure the similarity between different words based on their vector representations. Here these lines of code calculate cosine similarity between the word vectors. S1 stores similarity between king and queen, and S2 stores similarity between king and apple. The cosine similarity function computes the cosine of the angle between the vectors and returns a value ranging between -1 to 1. The results are printed on the console with the use of those two statements. In conclusion, what we can say is by calculating the cosine similarity between different word vectors, we can quantitatively measure the similarity between words in the embedding space. This measure is particularly useful for tasks like word analogy, word clustering, and similarity-based search.